going to share my screen and I'm going to ask some question about what we got last week. Yeah, I remember that I gave you that shape and I asked you to write down the code for this one, right? That's what we've done the last thing.
I wasn't there, but I did watch the
No,
audio
no, no.
recording.
I mean in your session, not the one later.
Oh yeah, I'm pretty sure I have a code of it.
Yep, yep.
Yeah.
Because in the other session we talked about the assignment number one, we're going to have in the advanced manufacturing the part for the assignment number one. It's quite
Yes.
complicated. Yep, and but I explained the things on how to make the lines and how to find the point, the intersection point, and I just show how to do it, but I didn't actually do the calculation because the dimension of the part is going to be varying from one student to another. And what am I going to do today? I try to give you something like a short assignment. And by this assignment, we are going to prepare the code for the next session. And when you come in next session, we are going to send you a link later on how to download a simulator. It's going to be something like the actual CNC milling machine. And then you have to upload the code you have on that simulator, make a short recording of your work, and upload it to the students. The session after is going to be almost the last one. We're going to do the G coding for the turning operation, or maybe we can do this one today. I'm going to work on this one today. So before we're going to move further, let me try to find the file which contain the CNC, sorry, the example or the assignment, and I'm going to share it here with everyone so you can start to work on it before next week CNC course. Okay. Well, now the main concept we have here is that you understand to find the points, we need to make an offset for the shape. That's with profile cutting. The same thing is going to be happening if you are going to work on the top surface. I didn't explain that a lot, but in all the cases, the only thing we need to do is an offset, find the point of the intersection, and reference them to the origin point, and you are going to find the point coordination and start to move the cutting tool center between them to the required depth in the case of 3 dimensions, and this will make you find out the proper code for the cutting tool to generate the geometry required. Now I'm still searching for that. I try to search it in another place. I'm doing that on a different screen. Okay, so let's talk about CNC. Okay, did I find this one? No, it's not on my download. I'm sure it should be on this external hard drive. Okay, now let's do the searching, and I hope that I'm going to find this one. However, I can, in worst cases, I can simply just sketch the part and send it to you. It's a 3-dimensional part. It's not that complicated. And again, to put on the paper here, and after that, again to start with. No, it's not very okay. I'm going to start with the turning operation. The turning operation meant to be easier, but the problem with the turning operation is the repeating of the process. Once again, you remember that in case of the turning operation, we cannot set the depth of the cut to the final shape. We need to do it step by step, and this is a process what we call the caning process or the cyclic process. We need to remove the layers one after the other until we're going to achieve the final diameter. So before that, these are some of the examples. I think I showed that to the student last time, and we're going to repeat that briefly. This was an example, a question defining exam for the advanced manufacturing a few years back. The good thing with this shape is that we have a symmetry line. So if I'm going to put a line here, this part will be similar to that part. If we would like to make the center in the middle, this will help us to indicate the point much easier, because we can find everything on the right side and then we can duplicate it on the other side, but changing the sign. So everything in this corner is going to have, oh, you remember this thing for the geometry. Here we are going to have positive x, positive y. Here we are going to have negative x, positive y. Here we are going to have negative x, negative y. And we have here a positive x and the negative y. So once again, just find one half and you will find the other. In that case, you can choose the datum point to be at the center. But we learned that for most of the machines themselves, we have a vise. And this vise have, we remember the shape of the vise. In the vise, we have a fixed jaw and we have the movable one. Now the movable one can go forward and backward, doesn't matter. For this one is going to be fixed. So I can set by default for all the machine that my datum point is going to be here and the part is going to be sitting here. Okay, and we can do the machining. Now, if I'm going to choose a wider part, is going to, of course, going to be extended to here, and the jaw will be sitting here. The problem is that if I'm going to set my datum point to be in the center, and I would like to do a different shape or different size for the part, that means that every time I need to set up my location of the datum point depending on the width of the part. Or I'm going to have a different setup for the machine each time I make a new part. So that's why we always prefer to have the datum point here, and the cutting tool will always going to understand that we're not going to hit the jaw of the vise while we do the work, and we always going to be careful that we're not going to go deeper than this area to hit the jaw. So this was the main reason why we need to select the datum point to be at this position. We always put it on the side of the fixed jaw of the vise, and this will make us to be able to use the same setup for multiple parts. Now, okay, now for this example, once again, the process was very simple. The tool we're going to choose is going to be the one which had the radius of this fillet. Why are we doing that? Because the movement of this cutting tool in this position simply going to create the fillet without need to go for G02 or G03 to make the cut. Just simple rotation, the radius is going to be printed here, and that's all. But here we have one trick, which was we need to reach this point. We're going down before we're going to perform the cut of the circular interpolation. Then we need to go up before we're moving to the G01. You always have to think logically about what the size of the tool you need to choose, and also what will be the movement and what will be the tricks we're going to have by changing from the G01 to the G02 and so on. So that's why I added these two extra steps here. One of the tricks I always was tricking the student with in the final exam, if I'm going to have a shape like that. Now, if I get to have a shape like that, and my cutting tool required to cut the arc, I get to make an offset shape of these two arcs. That's what we learned earlier. Now you can see that these lines are not going to be connected at all. So what I'm going to do is I'm going to measure something from here to the offsetted by the radius of my cutting tool, and make horizontal line. So my cutting tool will move from here to here, then moving horizontally to here before it's going to continue doing the G0 3 to the final position. Okay, now just let me check if I got something. I found what I'm looking for. No, I don't think so. I don't think I found the thing. Anyway, I got some simple material, but however, I will be able to contact my colleague and ask him for the engineering drawing for this part if I can find it by tonight. However, let's go to the part I would like to sketch. And this will be in 3 dimensions. And this is the old method to do the hand sketch and do the engineering drawings. Back in the old days, we take one side. So we take a look for the part from the side. Okay. And here we are going to have a higher level. And that's the dashed line. And we're going to have a hole inside. So this will be the side view. We always make something like a cross and make another 2 geometry for the part. I'll put the dimension at the end. So we do something like this one. Actually, this is, as I told you, an old experience for the thing. Okay, and from these horizontal lines, we make an arcs. We used to use something called the what's the name? Protractor to do the sketch for that. I'm sorry. And make the vertical lines. So obviously at the end, what we're going to have here, this will be the side view. Here we're going to have this will be top view. And this will be the other side view. So mainly what we're going to have from this one is we have the, that's going to be top view is here. Yep. This will be top view, and then we're going to have third view. Top view, what we have here is square shape from the top. And we're going to have a square sitting here. Maybe if I'm going to add something. Anyway, I will make it as simple as possible. Okay, and we have a hole in the middle. I don't think we need another side. So I'm going to give you the dimension of that. This one is 50 millimeters by 50 millimeters. The diameter of the hole here, phi, is 10. The depth is 10 millimeter. And what else do we have? The dimension for the square here. This will be, same thing, is going to be square. And it's going to go down by 20. This area is going to be equal to 15. So this will be 35 to the 50 is going to be, well, let's make this one 20. So 20, 20, and we're going to have 5. What else do we have? Oh, no, let's make this one 15. I just created thing from my mind, and this way I'm changing my mind. Okay, 15, this will be 25, and this will be 5 at the end. 5 millimeter. I just changed that to 20 because I would like to have the center of this hole not to be in the middle. So this will be at 10 millimeter from the side. Now, the height, is going to be very important to be mentioned. This height is 10 millimeters, and this height is going to be 40 millimeters. So that's the drawing we are going to have to sketch it in 3 dimensions. I'm going to sketch that in 3 dimensions, and we need to write down the code to cut around that and make the hole, and that's it. The 3-part dimension is going to look like the following. We always going to make the front face. Then we are going to sketch something by 60-degree angle. Okay. Obviously, what we have here is going to be 40 for the height and 50 for the side, because you know that the height is quite lower. Okay, and I'm going to make the other block at the top here with the dimension giving here. Okay, and this one is at the height of the 10 millimeters. And we have the hole and the top here. 50, 40, 40, okay, this 50 of course. And the dimension here is going to be similar to this one, 25 by 25 for the square at the top, and the diameter of this hole is 10. And we're going to have the height of this block is 10 plus 40 is going to be 50. So we're going to start up with the 50 millimeter block, remove the material just to have this square at the top with the hole in the middle. I would like you to work on this one, and later again to give you a little bit advanced than this one. I think that the best look for this one is going to be like that. Okay, so you can take a snapshot for that later and start working on it. So obviously what you need to work at is, if I'm going to complete the whole thing here as a dashed line to cover all this area. Okay, this will be my origin point, and everything is going to be a reference to here. Less than that is going to be minus 10 millimeters. Definitely, if I try to remove the material to the depth of 10 millimeters, you need to do it at least in 2.5 steps. The first step is going to be 4, the second step is going to be 4, the third step is going to be 2. So you write down the code of cleaning around this one once to the z of minus 4, then you copy paste the same thing to the z of minus 8, then copy paste the same thing to be to the minus 2. And then you're going to have a hole in the middle, and that's it. Okay, so that's what you need to cut around it. Okay, do it at the 3 steps, 4, 4, and 2, and drilling the hole, and that's it. It's only going to require to take a look to the top, make the offset lines. You need to go in a circle, then you need to go in a straight line to clean this area, because this area is wider than that. Choosing the cutting tool is going to be, you already had the hint, because the diameter of the hole is 10 millimeters. So you can use a 10 millimeter diameter to do the cut. That's it. This will be your exercise for the next session. Now, let's talk about the turning operation. In the turning operation, the part is going to be cylindrical, and it's going to rotate along the z-axis. Setting of the depth in this direction, this will be the x-axis. This will be negative x, this will be positive x, this will be positive z, and on this direction is going to be negative z. So for the turning operation, the datum point usually is going to be on the face of the work part, here, at the center of the face. Again, anything in this direction is going to be positive x, z, negative z, negative x, positive x. So the tool post usually going to move the cutting tool in this direction to be in contact with the work. You remember that we have different cuts on the turning operation. The first operation is we can do the face cutting, just remove a layer from the face. Then we can do the actual turning by removing the multiple layers. We can have the contour cuttings by making the curves. The problem is, if I'm going to take a look to the part from the side, we're always going to see it, of course, the cross section of the cylindrical shape and this plane. We're going to see a rectangular shape. This is not for the rectangle because I'm sitting away from the paper. Okay, and the z-axis is going to be at the center. We're rotating the part around this shape to the counterclockwise direction. So in this case, this will be my datum point. I will consider that everything in this direction is going to be positive x. This direction is going to be negative x and positive z and negative z after the datum point. All the functions we have for the cutting in the G coding for the turning operation is going to be the same like the one we had in the turning operation. i.e., if I'm going to move the cutting tool from this position to that position, this will be G01. If I'm going to move it in very small depth doing the contour, this will be from here to here, is going to be G02. And of course, I have to define what will be the radius of this cutting. Now, the problem is, in the case of the turning, if I would like to take the diameter from this amount to that amount, I cannot insert my cutting tool directly to this position. That's wrong, because this will damage your cutting tool instantaneously. The second thing we have is that usually in the case of the cutting tool we have in the turning operation, if it's going to be high-speed steel, it's going to have a sharp nose. If I'm going to have the carbide insert, it's going to have a round nose. Like that. And the round nose is going to be very small, actually. We have to do the compensation for the radius. That means we need to do the cut at a certain offset. In the case of the high-speed steel with the sharp nose, we don't have to do that because the contact is going to be directly with the work. For the other one, as I told you, we are going to have the contact is going to be here. So we need to consider the offset later. We do the compensation for the arc. It's something like when we do the offset in the case of the turning operation. Basically, I'm not going to do that because you can simply write down the full code without any compensation or the offsetting for the cutting tool. When you insert the code to the machine, you can mention that the radius is equal to, for example, 0.02 millimeters or 0.2 millimeters, and the machine will do the offsetting automatically and changing the whole code or just pushing the thing and making this compensation. The other thing we have for the turning operation is, you remember something in the turning machine is called the tool post. The tool post, if you remember it from the manufacturing, is the post which holding the tool and moving forward and backward, inside and out. It's holding the cutting tool in this position. The G coding should be defined the position of that point, because the CNC machine is actually dealing with this point. So you have to define what will be the value for the delta Z and the value for the delta X as a type of the setup for the machine. Something like when you define the datum point in the case of the milling operation. So these are some of the points we need to consider during the turning operation. Now I will show you an example. If I would like to cut a shape, well, actually, no, let me sketch the part itself. So I would like to cut a shape which is going to be similar to that. Something like the chest part. Okay, so this 1.5 lines, so it's going to be to here. So I would like to cut a part similar to this one. And I'm going to do that by the turning operation. The center line, of course, is going to be in the middle. So this will be my datum point. And again, this will be the positive x-axis. And this will be negative x-axis. And of course, this will be positive z. If I would like to cut this part, I have to start with a cylindrical shape. So the cylindrical shape, of course, is going to be filling all these things. So I'm going to make the actual envelope of the work. Okay, so this will be the actual shape, and I'm going to cut it to that shape. Again, I told you that we cannot set the cutting tool to that depth and start to move it in this way in the case of the turning, because we try to minimize the contact between the tip of the cutting tool and the work part. So we always try to do that by steps. So my first cut is going to be as following. I'm going to remove one layer. Second layer. Then when I reach this stage, I'm going to do it by steps starting from here. Another one here. And I'm going to have something like a step shape. That's going to be easier to be removed by the finishing cut. So that will be the cut I need to do. And this will be at the beginning. And later I'm going to do the final cut to make the arc. So to do that, I once again need to sketch these lines and find the intersection points. And this intersection point is going to be the point that the cutting tool is going to move to. The movement we're going to have in the turning operation is going to be as following. I think that, yeah, this was freezing. The cutting tool will be here. It will be traveled to here. We set the depth of the cut. Then it's going to move all the way down to perform the cut. When it's going to reach this step, it's going to leave the part, travel all the way down, then go deeper and do the same movement. Stop here. Going to leave the part. We're going to this position. We're going down and cut this layer. Leaving, going back, go to this third depth, cut a layer, going up, back, going down, do another layer, then go up, going to this position, and starting here, then perform the cut of the G0 to make this cut. Now, is that clear for everyone? Is that clear for you guys? Christian and Lisa? Okay. Now, Peterson, is that okay with you? Sorry to call you Mr. Peterson. Is that good with you? Did you understand the process of doing the turning? That means that the feed rate has to be really slow since the lathe is going to be rotating. Now, you remember that we have two types of the cuttings in the turning and the milling as well, which is we have the finish cut and we have the rough cutting. In the case of the rough cutting, the depth of the cut is going to be higher, the feed rate is going to be higher, and the RPM is going to be slower. In the case of the finish cutting, the RPM will suddenly going to increase, the feed rate is going to go slower, the depth of the cut is going to be less. And we can do the calculation for that. I think that we learned how to do that in the manufacturing engineering. Later, I'm going to show you how to do this approach actually in the CAD/CAM, but this will be a common session between the student who attending this session but not doing the advanced manufacturing. But anyway, it's going to be a part of the class of the advanced manufacturing subject. Now, another point we need to know here. When we set the X value, we're going to set it as a diameter, not as a radius. What I mean is, if the total diameter was 50, and the final diameter here, let's say, is going to be 44. And the arc we're going to have here it's have the radius of, let's say it's going to be 50 again. Just an example. I don't have something in mind. Later, I'm going to show you how to do the solid work to find the points accurately and then write down your code. Now, we are going to start the operation. I would like to take it from 50 to 47. So in that case, my X here is going to be 47. It's not going to be 47 divided by 2. Next one is going to be 44. So it's going to be X equal to 44 at this level. I'm defining the diameter I would like to cut. I'm not defining the radius I would like to cut. So I'm going to start with the first 2 lines to remove layers here until we are going to get the diameter from 50 to 44. We need to know about the length. So the length to here is equal to 70, and the length to second layer cutting here is going to be 67. So to write down the first cut, the first 2 cuts, to cut straight lines first, starting from this point going to that point, I'm going to do the following. Of course, you know that we need to put the introduction before we're going to write the things, but I'm not going to do it right now. I'll write down G00 and go to the X 0.00, Y, Z equal to 1 millimeter. The feed rate, let's say, is going to be 200 millimeter per revolution. Now, what I'm doing is I just brought the cutting tool to here. Is that correct to do the face cutting? When you do the face cutting, are you going to do it from the end to the middle or from the middle to the end? When you clean the face, end to the middle. Yep, it's end to the middle. Because at that case, we are going to have the minimum contact between the cutting tool and the work part, as you can see here. just going downward until we're going to clean the things. That's why usually you can see that most of the turn part, you can see actually, you can feel there's a notch in the middle, because we're going from the end to the middle and do the cut. So this line is wrong. So to remove a layer from the face, it's going to be G00 to the X is equal to. Now, I'm trying to get at the top here, where the diameter was 50, X 50, I'm sorry, 50.0, and the Z is equal to 100. Then G01 going to the X50, the Z is equal to minus 0.9. And the feed rate, let's say it's going to be 200. Then G01 going to the X00. Now I just brought the cutting tool to here, inserted by 0.1 millimeter inside the work part. Then I went to the middle where the diameter is equal to 0. Then I have to leave, go up. So G01 to the Z equal to 1. Okay, or G00, don't have to be G01. Then I'm going to start the operation again. So G01, then we go to the G00, the X is equal to the 47. Now at 47, I'm going to move horizontally along the Z-axis. The X will remain the same, the Z will be changed, and going to what will be the point, what will be the Z value to bring the cutting tool to here. I'll write down G01. The X will remain the same. The Z is equal to. So now we're moving in this direction until we are going to reach minus 69, correct? Minus 69.00, and we have to put the feed rate value, whatever it is. Now, I have to leave the things going up in the X direction, travel all the way down there. Then we go back to the X where it's going to be at 44 and repeat the trip once again horizontally to the X is equal to minus 66. So this will be next step. So G00, X is equal to, let's say, 52. Okay, then the G00, we always going to leave it like that. We travel all the way going down and do it like that. So G00 to the Z equal to 1. Then G01 to the X equal to 44. Oh, sorry, let's make it G00, 44. The Z remain 1. Then we're going to continue to do the cutting multiple times. So I'm going to complete this one on this side of the page, and I would like you to do the following. Now, when I'm doing that, usually when writing down the code, I'm simulating by using the following method. I consider that my pen is the cutting tool and my brain is a numerical control system. I'm reading the code and moving my cutting tool to make the lines and see if I'm doing the correct coding or not. The only thing, well, you can see that the process is actually going to be very simple because we're moving in simply 2 dimensions and we're always going to move in straight lines until we're going to have the stipple shape. Then we're going to have the final cut of the arc. It's just repeating the same code multiple times, and that's what makes it quite boring. And to cut such shape, which you can see, oh, it's too simple, it's going to take something about 5 to 10 times of the line required if we're going to do a more complicated shape in the case of the milling operation. Because the milling can move into the depth directly, while this one needs to do it step by step. And that's what we call the caning or the cycle cut, until we're going to have the approximate shape by roughing. Then we can finish it by the finishing operation. Maybe we didn't cover that in the manufacturing engineering, but again, to repeat the same thing for them. Okay, now what happened is that my cutting tool is in this position, and I'm going to send it all, sorry, in that position, higher, a little bit higher, and it's going to send it all the way to here to make the new cut where the diameter is going to be reduced from 47 to 44. So I move 3 millimeters in the way. So I'm going to send the cutting tool. Let's try it from here to make one line. X01 to the Z equal to minus 66. And of course, I have to define the feed rate again. Then I'm going to repeat the same steps here, going up and going back. So I'm going to write down the X00, X is 52, and let's say that the Z is going to be, I'll put them in one line just to reduce the line number, 1, and then we are going to go to the X. Oh, actually, I don't have to go back all the way back to here. I only need to come back to this position. So I'm going to be here. Then I'm going to insert the cutting tool in this position, going in another straight line, then going up to that position, going down, cut another line, going up to that position and cutting this part and going up. By that, I clean all this area and I'm ready to cut the final cut we are going to have here. To make this cut, I need to know what will be the location of this point and the coordination of that point. We said that this one is going to be something about 70 and the X is equal to 50. So minus 70 and 50, what we have here. Sorry, minus 70 for the Z and 50 for the X. And in that position, we have that the X is equal to 44. And the Z, let's say, is going to be equal to 15 minus 15. Now, for the G02, well, of course, that after we finishing all the cleaning, we're going to come to the point G00. The X is equal to let's say 47. And the Z is equal to minus 15. Then G01 to the X is equal to 44. Okay, and the Z remained 15. Then G02. Now why G02? Because we're going to turn in the clockwise direction. G02, I have to identify the location of the next point, which is going to be 50 for the X, and the Z is equal to minus 70. I need to follow that with the R value, which is, let's say, 50, and this will do this cut to finish the part. Of course, when I get to reach this point, I need to leave and go to the home position. So G00 to the X of 52 and the Z of 1. Done. I'm done the cutting. Now, well, from my point of view, I think that the turning operation is simpler than the milling operation. The only challenge is going to be about finding the point, number one. The second thing is don't lose the track. If you lose the track, you're going to lose the sequence and you're going to miss your way. You cannot find where you have been. And that's why actually I usually use the SolidWorks and make this one by hand first and number all the points. On this side, I make the table about the point number one, the X and the Z value. And then I'm going to start to move my cutting tool between the points according to the sequence. So this will be the point number one, this will be point number two. This will be point number three, this will be point number four. Point number five, and so on. So just keep making the sequence of my movement and then write down the code. Just remember that the X value is going to be setting the diameter, not the radius. And we're going to set the Z value to be negative from here, a positive from here, negative from this direction. Do you think that what I'm saying is look logic or is confused? Great. What about you, Lisa? Have you lost? Yeah. Well, it's not complicated, but it's lengthy. It's not complicated, but it's lengthy. Sorry for that. Yep. You can watch the video, Lisa, later. Yeah, it's not complicated. Once again, it's lengthy. So I will leave this one for you, and you can of course it's going to be you can pause the photo, and you can follow up the things. And I would like you to write down the rest of it. And we have many of the calculators, simulators available online. And I would like you to find one of these simulators and type the code and see what you are going to get at the end. They call it simply turning operation simulators. So let's try to finish that and apply it yourself on the simulator and see what will be the results. Actually, knowing in this coding, mainly the turning, is going to give you more advanced image about the milling operation because now you're going to a higher level. Well, I know that the turning maybe is not interesting for many people, but I think it's actually a higher level than the milling operation coding. Because you know that the milling operation, we just made the offset directly, then we did the cut. We cannot do the same thing here. Here, you need to do it as steps, then you need to cut it directly as a curve. Oh, by the way, some of the curves the question they had in Washington Uni, it was a dome here, then they had the concave shape. So they need to stop at a certain point and do the dome shape. And this was actually quite hard because you remember that we have the cutting tools are going to be, most of them are going to be left-handed like that, or this can be right-handed like this one. And this one actually cannot cut from here to here because this level is higher than that level. And for this one, when I get to reach that point, it's going to not cut this vertical shape. So the L is going to have some problem with that, but again, they still need to do it for their assignment. Okay, so if you don't have any question, I may have to leave now because actually I've been working since this morning to make recording for the manufacturing subject in the uni, and I had just before you I had 2-hour session for the CAD CAM. That's something actually again to share with you because I know that you need to understand about the CAD CAM operation by using the SolidWorks and the SolidCAM we have at the it's not the canvas, it's called the workplace. Did I mention that to you? Yep. So I will show you that what we had now. Now they replace the VMware with this panel. It's called the Citrix Workplace. The only problem I have right now is I cannot operate that. Oh, why? It's only share screens. Oh, yeah. I just remember that. Yeah. I don't know why. When I share the screen, it's showing black. That's very funny. Yeah, you're right. Well, maybe I try to do something else. I'll try, for example, again, to work on a single screen instead of two. And I hope this will work. That's one of the problem I had with this software. When I tried to play the SolidWorks, again, to show it now, I hope it's not going to be black this time. When I try to play the SolidWorks on the dual screen, it's also showing me a black screen. So let me see if, are you still see it black? Or now it's show up to you? You still see the black? Still black. Oh, that's really funny. Okay, now I'll try to do something else. We'll share the window itself. Is that the window we're talking about? Oh yeah, it's always going to show black. Yeah, I'm sorry for that. That's strange. That's strange. I'm going to find a way to show you the thing later. And as I told you, it's called the Citrix Workspace. And you need to search, again, to show you that, write down the name for you. Citrix. Workspace. Yeah, I advise you to download it now and try to install it, explore it before we're going to start the semester. And this will send again to reduce the hassle we're going to have if you just try to introduce yourself to it at the beginning of the semester. You can find the same thing, the same actually softwares that we will use in the VMware, but it's look like faster somehow. But the problem I had now is mainly for the storage area, because this meant to be linked to the OneDrive, and this should be done in the first step when you start to use the app. What's happened to me? I had an error with that. Now the app is working properly, but I cannot go back and relink the OneDrive to the app. And the problem is that the IT people telling me, "Oh no, it's working. It should be working." I take multiple snapshots, try to convince them that doesn't work, but they don't believe in me. Hopefully, they're going to solve the problem by tomorrow. Okay, so I'm leaving by now. And if you have any questions, you can come back to me at any time. We are going to run another session. Could we instead use another application with our SolidWorks software or on our computer? Do you use PC or using the Mac, Lisa? Okay, PC. Now, I think that the best thing is using this one, because during this semester, we are going to learn something about another software called the NX. The NX is similar to the SolidWorks, but it's by another company. And I will try to promote this software for the student this semester because it's very popular in the manufacturing. In the real life. So we are going to work in parallel between the SolidWorks and the annex at the same time. So try to get this one and try to use it. It's much better than downloading the SolidWorks to your PC, and you need to download the SolidCamp to it. But here is it's already. You can just simply start using it, and you can use the SolidCamp with it and do the assignment number one. Mainly, it's going to be assignment number one. Other thing we're going to cover in the advanced manufacturing is going to be the image processing. And simply again to be how to use the MATLAB to find the number of the circles or find the diameter of the circles or the length of the part by using an image. You need to change this image to monochrome, and then you're going to use the difference between the between the light spectrum to do the measurement for the pixels and transfer that to millimeters. So actually it's going to be a quite advanced semester this time, and I hope that you are going to be satisfied with the quality of the material we're going to cover this time. Okay, so once again, I need to go. I need to take a rest for 1 hour, then come back to work on another 2 sessions I'm presenting tomorrow at Western Sydney Uni. And one of them is going to be thermodynamics, and I didn't actually prepare this slide yet. So I'm going to see you soon, and hope that you're going to enjoy the rest of the time for today, and always remember to be safe and take care. Stop the recording now.